All right, hello everyone. Today we're going to be learning about a highly anticipated topic, some pneumatics. I know a lot of you are making your motor clamps, so this will be super helpful with that. So, to go over today's agenda really quick, we're going to talk about why pneumatics are useful. I'm sure you guys already kind of know, but I'm just going to give you guys another overview. How the actual system works, the pneumatics components. I'm going to go through each component and talk about how you use it and what it's for, and then general air saving techniques to help you guys maximize the amount of air that you have on your robot. So, first thing, why are pneumatics useful? Pneumatics are super useful because they allow for easy linear motion. So if you see in this, I should probably come over here, but if you see here, motors have rotational motion, right? Things rotate. So they're really good for things like drive bases, for intakes, etc. Things when you want them to move like forward and back, this is where pneumatics comes in, because it's really hard to convert a motor's rotational motion to a linear motion. And pistons make it really easy to do that. Additionally, pistons don't count towards your 88 motor limit. So for example, if you say, oh no, I have another mechanism I need to do, but I'm out of motors. What you can do is you can try to make it out of pistons, because these aren't limited by, you can have unlimited pistons on your robot. And technically, these are limited by air capacity. I'll talk a little bit about this later, but you can only have a set amount of air on your robot because you have a set amount of tanks that you can use legally and a set amount of PSI that you can pump the tanks to. So just to go over that really quickly. So here's the official rule from the game manual. It says R13, R23, sorry, pneumatics are limited. So you can have up to 2 of these tanks on your robot at once. No more, you can have less, but up to 2. And you can only charge these up to 100 PSI. So we have this air pump, pretty standard. So when you pump these up, it'll show you your PSI on here, and you can't pump to more than 100. And yeah, that's about it. So there's actually 2 different types of pneumatics tanks. So these came out a couple of years ago. These were the standard up until they released these new tanks. So as you can see by these graphics here, this is about, I think 50%, no, 66%, no, 33% smaller. These are 50% bigger. And so they can hold a lot more air, even though they hold the same PSI. Additionally, this is actually heavier than this. So what I'm trying to say is that these new tanks are both lighter and hold more air. So if you can use these, they both work. So to go over really quickly how pneumatic cylinders work. So you've all seen one of these, right? These are standard. So a very quick clarification. These are not pistons, these are pneumatic cylinders. The piston is actually the thing that moves in and out. The entire system is called a pneumatic cylinder, but I've heard a lot of teams call the entire thing a piston. It's not too, don't need to get too much into technicalities, but the official name is a pneumatic cylinder. But essentially, if you look at this diagram, right, it's pretty simple. You have this little suction inside, this little, blocker, and when you push in air from this port, let me see if I can hook something up really quickly. Let's do this. So when you push air in to the back, it'll push this piston rod out. So let's see if we can do that. So as you can see here, the piston is not extended, but when I push in air on the back valve, you can see it extends out like that. It's very simple. And when you want to do essentially the opposite, when you want it to retract, what you do is you push in air from the front. So hopefully, there you go, it retracts. Very simple mechanism. And that's basically how pistons work. So now I'm going to go over really quickly all the new pneumatic components, because they released these a couple of years ago. Even I had to do a little bit more research on these to make sure that I knew what I was talking about. But these are pretty complicated, so just make sure you're paying attention. First thing, air tank and tubing. This is really simple. You have your standard air tank, like I showed earlier, right here. This holds all of your air. Oops. This holds all of your air, and you can have a maximum of two of these on your robot. Second, you have the tubing, 4mm tubing. This connects everything on your pneumatic system. So connects your tank to your solenoids, to your pistons, whatever. If you want to use air, get air to a part of your robot, you're using this. And this tubing cutter down here, very simple. You can use like regular scissors or like cutters. Anything works, but I prefer to use these because they allow for a very clean cut. Additionally, just something to note. When you're cutting these pneumatic tubing, it's kind of hard to see, but whenever you want to put these in a port, it's very important that you cut these very flat and clean, because if you have like a jagged edge, it's very prone to leaking, so that's something to keep in mind. Pneumatic cylinders. So these, the new VEX pistons here, they have three different versions. So there's the 25 millimeter stroke, 50 millimeter stroke, and the 75. It is exactly what it sounds like. The 25 millimeter stroke has a 25 millimeter extension, and so forth for the other pistons. And you have three different types of these. So if you need something that needs to extend very long, you want to use the 75. If it's very short actuation, you might want to use 25. And just basic laws here. A longer piston uses more air because you need more distance to push that and therefore more air. A shorter piston needs less air. So depending on your air needs and your distance needs, you can find the perfect piston for you. One of the really cool things about these new pistons is I don't have, let me grab a number. So one of the really cool things about these new pistons is that they can screw directly onto nuts. The standard Kep's nuts and nylocks. So if you want to attach something, you can just use this. They screw on very easily. So that's super cool. And obviously, if you have more pressure pushing the piston out or in, then obviously it'll have more force pulling or pushing. That is just something. So as your robot goes through a match, it starts to run out of air as you're using it. Note that at the end of the match, if you're at like 30 psi, your pistons may not be able to like retract fully because there's not enough air behind it and therefore not enough force. So that's just something to keep in mind. And then really quickly, just to point them out, these are the two ports for the air. So just to make sure to connect both of those to make sure you don't have any leakage. Quickly talk about electronic and manual flow control. So we have a shut-off valve fitting over here. This is basically you have one wire going into it and one wire out, and you can turn the knob to cut off that air. Pretty simple. This is a little more complicated. This is what we call a solenoid. This one specifically is a double-acting solenoid. It sounds fancy, but essentially what it means is it can push air one way or it can push air the other. And you can see here, I did a labeling here. So essentially, the P ports, which are on the side, they're not labeled on here, unfortunately. But if you see the P ports, they're on the side here. That's where the air goes in and air comes out. The A and B ports, these are the ports that you would connect traditionally to your piston. So for example, I don't have the fittings here, but you would have one of the piston edges connected to one side and then the other connected to the other port. So when the piston switches between the two ports, it'll extend and then retract, and that's a basic pneumatic system. Additionally, the two R ports, they're under the P ports. They're kind of hard to see, but they're right here. Essentially, these just release the air. They're also easy mounting points. If you're not using them, you can just use a zip tie and zip tie them on. That makes it really simple. To make these work, to actually power the solenoid, what you do is you take one of these wire adapters. They call them the double acting solenoid driver cable, but it's just a fancy cable that is essentially this, and then this plugs into the bottom of your brain. So it's not the motor ports, but on the side there's like little rectangular slots. That's where you plug these in. Pneumatic fittings. So there's 6 different pneumatic fittings. These aren't super complicated. All you really need to know is that the straight male fitting is kind of like a one-size-fits-all. So if you're in doubt, you probably want to use this. This can connect to your air tank, can connect to your solenoid, can connect to your pneumatic cylinder. It can pretty much connect to everything that you need to power. So whenever you need to connect something to another thing, you basically put the tubing in your adapter, and then you put that in whatever pneumatic component that you have. The elbow fitting is essentially the same thing, except it's at a 90-degree angle, an elbow. This is for when maybe the piping is weird and you want to manage your pneumatic piping and you want to angle it somewhere. This makes it a lot easier. Airflow valve fitting. This is essentially the elbow fitting, but you can connect the amount of air that goes into it. So for example, let's say your tank has 100 psi, right? But for some reason, you want to make sure that the piston extends slower. And so this is sort of what that's for, right? So if you want a piston to extend slowly, maybe to make sure a mechanism doesn't bang into another mechanism, that's what you use. But generally, I would recommend using an elbow fitting because that allows you to use the maximum amount of PSI to produce the maximum amount of force. A T fitting or a splitter is essentially what it looks like. You have 3 different ports going into it, and so therefore you can connect up to a maximum of 3 pneumatic tubing, and that allows you to split off to different mechanisms pretty easily. This one is used a lot less often. It's mainly used to connect the air pressure gauge, and I'll talk about that a little bit later. And the 4mm plug, so if you have a bunch of fittings, for example, that you don't need, just for example, say this one, you can use one of these plugs and then push it in, and that ensures that you don't have to do any fancy stuff with like trying to zip tie it or anything. You just push that in, and that'll make sure that you don't have any leaks out of that port. Miscellaneous parts. So air pressure regulator. So this is essentially like an overarching mechanism that sort of regulates the amount of pressure to connect to your connected systems. So for example, if you have your air tank, and then that's connected to your air pressure regulator, and that's connected to your piston. Essentially what this does is say, let me set the air pressure regulator to 50 psi, right? Essentially what it'll do is it'll take the output from this, control it to 50 psi, and then feed it to whatever is connected. And so the benefits of this is you get more actuations, right? So if you push 100 psi through it, it'll dwindle faster than if you push 50 psi consistently through it. It allows your mechanisms to be powered via air more consistently because the same amount of psi is being put into it. And so it's generally very helpful. I personally don't use it because I like using pneumatics at their full force, but it's really up to you. Air pressure regulator bracket, very simple. This is just what mounts that. That's pretty much it. And then the air pressure gauge, this is super helpful. You can connect this to your air tank or your entire system, and it'll tell you how much PSI is in your system. So this is really helpful when you're like, should I go through the bother of like refilling my tank? You just look at this and then you just say, okay, you know what, we're at a good pressure, we don't need to refill. So that's just super helpful. General air saving techniques. So these are super cool. Basically, like I mentioned earlier, you can have a limited amount of air on your robot because you're limited to 2 tanks and each tank to 100 psi. So, first thing, very important, when you're pumping your pneumatic system up for the first time, you want to check for leaks. This is very obvious. What you do is you take your robot, you pump it up to 100 psi, and then you listen. Because if you generally can hear, you go to a quiet place and you listen. If you can hear a leak, there's probably a leak, and you have to find that and then regulate that. The most common sort of ways that air can leak out is if, like I mentioned earlier, if your pneumatic wiring is cut awkwardly, then when it goes into the fitting, it might leak out. Or somehow you get a scratch on your pneumatic pipe, or there's a puncture, that can also cause a leak. Or it can also just be a faulty solenoid. Number 2 air saving technique is minimizing the tubing between the solenoid and the cylinder fittings. So this is actually super important. So when you have a solenoid connected to a piston, the amount of air that is used in that one actuation is the volume of the cylinder plus all the volume between that solenoid and that piston. So all of this piping. So when you have, just say, an unrealistic example, like 10 feet of tubing between your piston and your solenoid, all of that air within that tube has to get released. That is air wasted. That is air that's not being powered, that is not powering your cylinder, that is just going in the tubing. And that gets all wasted. So you can see here, this is an example from our previous robot. You can see how you have the solenoid here, and then you see how this tubing is super minimal between the piston and the solenoid. So you want to make sure to minimize that distance. Additionally, you want to make sure that you can kind of see it a little here. You want to minimize that distance, but if you bend your actual pipe, then it'll cut off all of your air. So you want to make sure that sort of curve is very smooth and make sure that you're not like pinching it with any zip ties or anything. Number 3 is using rubber bands to passively actuate and retract the cylinder in one direction. So this is actually really cool, and you can see this in function here. So just to try to model this, we have a piston like this, right? And we want to use it to push up and then push this lever down, right? So when you extend it, it'll push this lever down. But let's say we don't want to use too much air, right? We're using a lot of pistons already. We don't want to add extra air to push it back in. What we can do is you can use rubber bands. So you can see here, the rubber bands are pulling this into the piston. So as soon as we release the air from pushing it out, the rubber bands will passively retract it in. Therefore, you can use the half as much air as you would normally use. And especially when you have a mechanism that only needs to be really strong in one direction, this needs to be very strong when you're holding a mobile goal, but it doesn't need to push the mobile goal out, right? So that's a very good candidate for using rubber bands, and that's how you save a lot of air. And I think that's about it. If you guys have any questions, come find me after, but thank you guys so much.
Thank you. Thank you.
I had one question.